My name is Jacob Holmstrom. I will be narrating the group project for Tim Colchin, Tim Elsner, Jake Holmstrom, and Sanjina Karki. This is our final presentation for Business 605. The data that we used consists of 20 variables, has a total number of participants numbering 100, consists of 3 different cultural identity breakdowns: African American, European American, and Hispanic. And the gender orientation possibilities are male or female. The age groups identified a range of 18 to 64. Here we look at the variable view of the data set, just so everybody has an understanding. On the left-hand side, you can see the name with gender, cultural identity, then the type. 1 or 2 of those types have to be changed just to run a couple of things. You also see the values, none are missing, columns. But then there on the right, you see the measure, nominal versus scale, and everything is going to be either nominal or scale for this presentation. The methods that we use: observation number 1. We're going to test salary and its dependence on cultural identity, age, and gender. We're going to do that using an error bar chart and a univariate ANOVA. Observation number 2, salary and its dependence on satisfaction with the company, satisfaction with online training, and also with traditional training. And we will repeat the methods we used for observation 1. We will use both the error bar chart as well as the univariate ANOVA. In correlation type number 3, in method number 3 rather, we'll do a correlation. We'll do 3 different types, and we'll do the Pearson and the Kendall's Tau. Again, the Kendall's Tau is a non-parametric test for ranked data. So in that, we're going to compare the proportion of concordant to discordant pairs. And in observation 1, we're going to be looking for a correlation between salary, age, grade level, years of education, experience, company experience. And then for number 2, we're going to look for a correlation between salary and those 4 variables. And then after that, we're going to search for a correlation between salary, gender identity, and cultural identity. Here, we are looking at an error bar graph comparing cultural identity and gender to salary. Among the gender groups, we look to see if cultural identity is statistically different. Because the error bars are near copies of each other, we can guess that there is no statistical difference in salary between members of the same gender group as compared to each cultural identifier. However, we need more proof than this, so we continue with the univariate ANOVA. In looking at this data, we are trying to determine if there is a significant relationship between gender or cultural identity and their individual or combined impact on salary. For gender, we have an F ratio of 258.135, suggesting there's a strong relationship between gender and salary. This, combined with a p-value of less than 0.05, tells us that we are extremely confident that the relationship exists. The cultural identity has an F ratio of 1.005, and this just meets the criteria of suggesting a relationship exists. However, the p-value is 0.37, telling us that the results we obtained are most likely a result of chance rather than any correlation. When combining both gender and cultural identity, it yields an F ratio of 0.32, telling us there is almost no relationship between the 3 variables. Combining that with a p-value of 0.96 tells us that there is a 97% chance that any relationship is purely random. When comparing the data with the error bar charts from the previous slide, these results correlate well with our inferences and our initial assumptions based on that data. In the error bar chart on the left, we see some interesting results. The chart suggests that there is no interaction between satisfaction with the company and salary. However, we can clearly see a discrepancy in pay based on gender, and we'll address that correlation later. In the error bar chart on the right, we've broken down the comparison into 3 cultural identities. With the salaries averaged among the groups, we see that there does not appear to be a correlation between satisfaction and salary. This chart also shows the limited, if any, relationship between the cultural identity and salary. We do have a couple of salaries that are outliers and appear to be skewing the data, which is why AA satisfaction score 2 and H satisfaction score 1 appear the way that they do. In running a univariate ANOVA, we try to find a relationship between satisfaction levels with the company, with online training, or with traditional training and salary. From this data, we will discuss the only item that appears to be statistically significant. With an F ratio of 2.685, which of course is greater than the required 1.0, and a significance value less than 0.05, we can infer that there is a relationship between satisfaction with the company and salary. Drawing back on previous slides, I remind you that gender appears to be the most statistically relevant variable when trying to predict salary. As promised, now we're going to do the Kendall's-Tau correlation for non-parametric variables. Now here we're going to find some similar statistics. Again, we find age and experience to be have a pretty strong correlation at the 0.492, and again, p-value of 0. So of course that exceeds the 0.05. We didn't really find too much of a difference from the Pearson and the Kendall's-Tau. Some of the values are in fact lower. Again, the 0.492. Even the age versus years of experience is lower, even though it's only 0.002 lower. But there is some difference in the values. But overall, we get pretty much the same information. So anything that we were able to infer from the last correlation, we can infer in this one. any correlations between salary, effectiveness, satisfaction with company. Here we're pulling back those satisfaction criteria, looking to see if we can find any type of correlation between somebody's salary, how good they are at their job, how much they like being with the company, how much they enjoy online training or their satisfaction level versus, again, satisfaction with traditional training. Drawing on what we know about the correlations, again, we're looking for anything with a value greater than 0 and as close to plus or minus 1 as possible. Now, what's interesting is that as we look at the largest value, in wrapping up the last correlation that we did, it's pretty evident that we can say with a pretty high level of confidence that there wasn't any real correlation. In this last correlation, the one we're calling observation 3, this is actually the one that we've been waiting to get through throughout the bulk of this presentation, mostly because we saw some information in the first error bar chart that implied some of the things that we are going to see here. For instance, salary and its correlation to the varying examples that we have. For instance, salary with cultural identity marked as Hispanic. We see that there is a very strong negative correlation there at a minus 0. And here we have the Kendall's tau, and going back again to that same variable, the gender female and its correlation to salary. Here we have a value of a correlation coefficient of 0.08 to the negative. Now that implies a much weaker relationship than the last one. The last one, again, was the negative 0.13. And we have a p-value of 0.33, which makes it appear that it's even more random than the last one. Drawing your attention again to the salary and cultural identity labeled as Hispanic, again, we have consistent data in that we have the minus 0.222 for our correlation coefficient, and again, a p-value that is meeting the criteria of the 0.05, less than 0.05. So that's basically telling us So here again, we're just sort of wrapping up the last group of observations that we looked at. Again, the correlations between salary, age, grade, etc. Some things that we looked at here as far as correlations confirmed what we already knew, and then some things, or what we were inferring, and then other things sort of debunked some of the things, or maybe said that the correlation wasn't as strong as we had originally thought at the beginning of the presentation. So, as everybody likes to say, the data will out. Well, I think in this situation, we need to find a different way to correlate things like why gender and salary are displaying such a discrepancy as we saw in the first slides. And in closing, we basically want to tell everybody thank you for taking the time to listen to our presentation. We think we put out some good information, and we think we drew some good correlations from which we can infer some good causations. So, again, thank you for taking the time to listen to us. On behalf of myself